finish up section 1.6 here by looking at reflections, which is another type of transformation. It is also a rigid transformation in that the shape does not bend or stretch, but it will keep the same exact shape. But reflection, as you probably know, is kind of like flipping it. We're going to flip it across the x-axis or the y-axis. So we consider a function f of x, y equals f of x, if we put the negative in front of the f of x, which means that the y is being negated. So a point up here, we're coming down here, we're going to reflect this across the x-axis. However, if we negate the x, y equals f of the opposite of x, as compared to the original graph of x, we're going to reflect this across the y-axis, because the x will change to its opposite. So what I'm going to do with this example is I've given some kind of a little graph here, y equals f of x, and I'm going to graph y equals the opposite of f of x. So I'm going to look for these three key points and see how they change. Now, if you reflect something, as you can see, the opposite of f of x, if you reflect it in the x-axis, the x-intercepts will stay the same. So let's say I choose, let's go with the red this time. The x-intercept is going to stay the same. This is going to stay exactly right here. But this point 2, 1, 2, 3, this point 2, 3 is now going to become the point 2, negative 3. 1, 2, and then down 3 to here. And then this point here, which is 1, 2, 3, 4, 1, will become 4, negative 1. And even though I'm going to freehand this, and you should be using a ruler, whoop, there we go. You can see that my graph of y equals f of x has been reflected for y equals the opposite of f of x. Remember, the negative in front of the f of x means you're reflecting it in the x-axis. This is going to be a reflection in the y-axis. So as you might guess, if it's a reflection in the y-axis, the y-intercepts are going to stay the same. So I'll use a different color here, and I'll do this one with the y-intercept staying the same. So we'll do this one in brown here, and then we'll do this one, and we'll say we've done this one here in red, kind of color-coded here for us. So what's happening here is that the x values are changing. This key point here of negative 1, 0 is going to become positive 1, 0. This key point here of 2, 3 is going to become negative 2, 3. And this key point of 4, 1 is going to become negative 4, 1. And I'm going to do my best to draw this one. And again, you would use a straight edge to help you with that. And you can see the graph, how it's a reflection of the original. So this is y equals f of the opposite of x. And then this guy down here is y equals the opposite of f of x. Now, got a couple problems over here. You can see one of them is highlighted there. As I mentioned before, when you see it highlighted like that, that means that it is a problem that came off of the review. And so what we have here, we have the steps for graphing multiple transformations. So there's not always one. Sometimes you have to shift, sometimes you have to flip, sometimes you have to stretch or shrink, all in the same problem. So when you have multiple transformations, follow this game plan here. Do your horizontal translation first, then any kind of horizontal, vertical, or stretching or shrinking, and then reflections, and then finish it with your vertical translation. This is a good way to go through this. So I'm going to do two examples. I'm going to try to do them both here. And what I'm going to show you is I'm going to do this one stage at a time, starting with the parent function. So for part A here, the parent function is the absolute value function, f of x equals the absolute value of x, which we know would look like this. So I'm going to just kind of quickly sketch that, kind of roughly sketch that. It would look something like this. Okay, now again, I would do this in pencil if I was doing this on paper, because what I want to do now is I want to first do any kind of a horizontal translation. So the horizontal translation means I'm shifting this V-shaped graph 2 units, because of the minus 2 here, to the right. So now my graph looks like this. 2 to the right. Okay, now I'm going to get rid, which is easy for me to do because of the markers, I'm going to get rid of my original graph. Now I'm at the step where I've done the minus 2. This is y equals the absolute value of x minus 2. Now I'm going to do any kind of horizontal or vertical stretch, and that would be this 3 here. Forget the negative for right now. I'm going to graph it as if it's just 3 times that. So what that's going to do is it's going to stretch it vertically. So like for example, I'm going to keep the same, let's use a different color here. I'm going to keep the same x-intercept, but this point at 0, 2 is now going to be at 0, 3 times as much, 0, 6. Let's see, 1, 2, 3, 4, 5, 6. It'd be way up here. And then this point here would correspondingly be 2 over and 6 up as well. So it would be up here about. So, should have made a little taller graph. Let's see what I can do here. Oops. So now my graph looks something like this. And I'll get rid of this. And this. And now I have y equals 3 times the absolute value of x minus 2. Now I'm going to do there's no more stretching or shrinking. Now I'm going to do the reflection, and since the negative is in front of all this, this is going to be a reflection in the x-axis. So again, my x-intercept stays the same down here. But remember, this was 0, 6. Now it's going to be 1, 2, 3, 4, 5, 6. I made it long enough this way at least. 0, negative 6, and 4, negative 6. So my graph is going to look something like this. And this would be y equals negative 3 times the absolute value of x minus 2. And I'll get rid of this. Okay. And what's left? What's left is the minus 1. The minus 1 is my vertical translation. I'm going to shift it down 1 unit. So I'm running out of different colors here. Let's go to this brown. And 1 unit down would be here, here, and here. So it's going to look something like this. Oops, I missed. There, I got a better shot at it. So let's get rid of the one in red. And now I have the graph of this. It's kind of light. I hope that you can see it. It looks like it's showing up on my monitor, so I'm hoping that you can see that okay. This key point right here is 2, negative 1. Alright, that's this guy right. Now this next one, very similar problem. Very similar problem, except, again, I'm going to emphasize that this type is on the review. This is a problem that was right off the review. This one is just about like it. In fact, it's a little extra tricky because it's got one extra step. So if you can do this one, you should be able to do this one as well. I'll go ahead and go through it. Alright, that one's done. And let's see what we can do here. Let's start with the parent function, which again would be this. And that would be the y equals absolute value of x. Now what I'm going to do is I'm going to do any kind of horizontal translation. So the plus 5 here means I'm going to shift this 1, 2, 3, 4, 5 units to the right. 1, 2, 3, 4, 5. It would go right here. And 1, 2, 3, 4, probably up here would be 5. So it goes something like this. And 1, 2, 3, 4. We'll go up 4 to kind of keep it balanced. And so it's something that looks like this. So let me, that would be y equals the absolute value of x plus 5. So let me get rid of this. Now after you've done a few of these, you can kind of start combining your transformations, so you don't have to do, if it's got 5 transformations, you don't have to do 5 different graphs. But while you're new at it, I might suggest that you go ahead and go through these steps. It really reinforces the ideas anyway. So let me get rid of this also. So that's this guy. Now the 1/3 is a shrink horizontally by a factor of 3. So instead of going up here at 6, or see that actually that was at 5, and that's at 1, 2, 3, that would be 3, 3, so that would go down to 3, 1. 1, 2, 3, 3, 1. So it's going to flatten it out a little bit this way. And let me get rid of this. This is y equals 1/3 absolute value of x plus 5. And this stuff in red here. And I think that's pretty close to having it. And now there's no reflection of like there was in the last example, but there is a -2 here. So that means I've got to drop my graph 2 units downward. So this was at 1, now it's down here at -1. This was at 0, so now it's down here at -2. And this was at 1, so now it's down here at -1. So here we go again. And I have this flattened graph. Let's see. I don't think I quite got that one right. There, we got it. And it should look like I just took this green graph and dropped it down 2 units, and there's my guy. Now, if you are doing this on graph paper, be very careful as far as getting kind of sloppy, especially if you do what I've done and do repeated graphs. I was able just to kind of erase it with my fingertip, but as you're erasing with your eraser, you're going to probably take out part of the axes and things like that, so be very careful with your steps. But that's how I go about graphing these types of graphs that have multiple transformations. And again, it takes practice, practice, practice.